Hi, I'm Andrew Thomson. I'm an archaeological conservator here at the St. Augustine Lighthouse Maritime Museum. I'd like to welcome you back to the Conservation Lab. The other video you saw a little bit about the equipment and what we do here. This is going to be about some of the artifacts that we've worked on from our shipwrecks. Alright, so what we are looking at here right now is an example of metal artifacts from our shipwreck Storm. This is actually one of the first ones that was found on site. So what this is a series of nested copper cauldrons. There's 4 in total, and they were all inside of each other. So this was the outermost exterior, and then this was inside that, that was inside that, inside that. When our divers first saw this back in 2010, it was just on the surface of the sand, so they noted that. But when they came back the next summer, they saw it, almost didn't recognize it, because the outer layer of concretion had disappeared, and this exterior-most copper cauldron had almost completely corroded away. So they brought it up and decided to do the conservation on it right then and there. So we brought it back to site, took photos, gave it a number, x-rayed it, just to double check, make sure if there was anything else in there. And then we started the manual process of removing all of the unwanted material. So that concretion, made up of sand and shell and sediment that's hardened over hundreds of years, used a little tool called an air scribe. It's a pneumatic chisel about the size of a pen, so it's a little jackhammer I have control over. Took off all the concretion as much as I could, and then started popping the cauldrons out of each other. Then put it into electrolysis. So the electrolysis process is you hook the metal artifact up to a cathode on a power supply. That's the negative. And then you have metal outside of the artifact that's hooked up to the positive anode. That is all submerged into a caustic solution of filtered water and soda ash, sodium carbonate. That electrolyte helps the process of when you flip on the electrical current, goes through everything. It actually draws the sodium and the chlorides and all the other unwanted material out of the metal into the solution, so that when you dump that, you put in a fresh batch. You keep doing that over and over and over, you get all the chlorides out. That's what causes the corrosion. So when it's finally rinsed and we seal it up, it won't fall apart anymore. It'll be nice and stable for display. So we're just in the final processes of doing all the paperwork, final photographs, all that good stuff, so that we can put this on display into the shipwrecked exhibit. So hopefully when you folks come back soon, you'll be able to see this on display with some of the other artifacts. So what we have here is another artifact, which is actually an organic. So this is going to be a much different treatment, much different option of investigation, as well as the previous copper artifact I was talking about. So this is actually leather. When we are in the initial phase of investigating what an artifact is, when we bring it up in that concreted form, we take it back into the x-ray room. So if it's metal and it's real radio dense, it'll show up nice and bright. We can kind of figure it out from there. If it's organic, think of when you go to the doctor's office, you're just going right through, you don't see any of that. So this was a surprise for us. This was at the top of the concretion of the x-ray, and we couldn't see any of this, but we could see what was inside. You notice there's a nice big hole there. That was filled with nails. So this was a nice leather pouch, sealed over like that, full of nails. So when the nails all appeared in the x-ray, this was also next to a hammer, a padlock, some pretty cool items in there. But we just were going to set it to the side and let one of our volunteers work on picking the nails apart. Because we have thousands and thousands of hand-wrought nails. But as he was air scribing, he got into the surface that looked a little different. We quickly realized that it was leather. So we started taking it all apart, cleaning it off very carefully, and it's in really, really good condition. You can actually still see some of the stitching along the side here. So it's really, really cool. But since the stitching popped on this side, I was able to pick apart, dig in, chisel away, chip out, take all the nails out, because the treatment for organics is bad for metal, and the treatment for metal is bad for organics. So what we do from here is, once we get all the thing cleared off, is we'll try to put it in a chelating agent. Put in a little ammonium citrate that helps leach some of the iron staining out. And then from there, we'll put it into, rinse it in some water, and put it into polyethylene glycol. And there's different types of PEG treatment. So there's big molecules, small molecules. So you kind of have to find the right mix, but this just sits in warm PEG. It's kind of the same consistency as like antifreeze. So when this is sitting in there, it'll soak in, it'll actually displace all the water and the chlorides out of the cell walls of the organic structure. If it sits in there long enough, it becomes stable, we take it out, and then we'll also do a kind of sealing process. And then when that's done, it'll be nice and stable in the atmosphere. We can put this on display as well. But that PEG treatment takes a very long time. It's almost a year from start to finish. So this we're hoping to get in very, very quickly, but this will be on display a little later when we reopen, you folks come back to the lighthouse. All right, well, thank you for stopping by and checking out the Conservation Lab here at the St. Augustine Lighthouse Maritime Museum. We hope to see you again real soon. Come in, ask us all the questions, and check out the artifacts. Thank you for your support, and remember to love your lighthouse.